Hello everyone, welcome to Java Velocity. If you are looking to master Java and unlock incredible opportunities in the tech world, you are in the right place. Java powers some of the biggest applications from web development to AI, finance, and even space exploration. In this series, I will be taking you through Java, teaching you some of the most important concepts in Java as well as practical aspect of Java. Why should you take this course? Java is one of the most in-demand programming languages used by companies like Google, Amazon, and Netflix. Whether you are a beginner or looking to level up, this series will guide you step by step. If you are preparing for Java interviews, understanding core concepts, design patterns, and real-world applications will set you apart. I will show you how to crack Java interviews with confidence. With Java, you can develop web applications, Android apps, enterprise systems, cloud solution, and even AI models. Did you know that Java is used in financial trading system, banking applications, and even the backend of large-scale website? So in this series, we will cover Java fundamentals, object-oriented programming, Spring Boot, microservices, databases, and even advanced topics like multi-threading and performance optimization. Each lesson will be a practical, beginner-friendly, and packed with hand-on project. So, are you ready to become a Java pro? I would like to encourage you to take this course. So, let us begin. I want to tell you a little bit about Java or a small history about Java. So, Java was developed, it was developed by James Gosling. It was developed by James Gosling in the early 1990s. Then in 1995, Java was officially released and quickly gained popularity due to platform independence, which was achieved through the Java Virtual Machine, JVM, which stands for Java Virtual Machine. In 2010, Sun Microsystems was acquired by Oracle Corporation, which now maintains and develops Java. So, I want us to go to what are some of the features. What are some of the features of Java? What are some of the features of Java? Features of Java. So I want to take you very fast through this feature. The number one feature for Java is that Java is a platform independence. Platform independence. That is number one feature for Java, platform independence. So what does platform independence mean? What does platform independence mean? Platform independence means that Java programs are compiled into bytecodes which can run on any device. As long as that device has got a JVM, Java can run on that device. And therefore, we usually say that Java is you write once and run anywhere. Write one and run anywhere. The number two feature of Java is object-oriented. Object-oriented. So, as we are going to see later, is that Java follows the object-oriented patterns like encapsulation, it follows inheritance, polymorphism. It also follows encapsulation. So these are some of the object-oriented concept. Number 3 feature of Java is secure. Java is secure. Why do we say that Java is secure? Why do we say that Java is secure? The number one reason why we say Java is secure is because Java provides a secure runtime environment with features like bytecode verification and security manager. Number 4 feature of Java is it is robust. So it has got strong memory management, exception handling, and type checking, which make it very reliable. Number 6 feature is its support for multi-threading. Java supports multi-threading. It has got built-in support for multi-threading, allowing concurrent execution of tasks. The other feature of Java is distributed. So what do we mean by distributed? When I speak about distributed, I mean that Java support networking capabilities, making it suitable for distributed application. Number 7 is high performance. So Java is one of those programming language that have got high performance. It has a capability called JIT, which stands for just in time compilers, which enable high performance execution of Java programs. So these are some of the features of Java. These are some of the features of Java programming language. So there are so many other features, but I would like to encourage you to keep on doing research on these Java features. They are really helpful in the world of software development. Very, very, very helpful. So I want us to talk about JVM. So it is good that if you are a Java developer, understanding of JVM is very important. And basically JVM stands for Java Virtual Machine. Java Virtual Machine. This is the core of Java's platform independence. It is an abstract machine that provides runtime environment for executing Java code. So this provides runtime environment for executing Java bytecodes. It provides runtime environment for executing Java bytecode. The JVM performs several tasks. What are some of the tasks or functions of JVM? There are several functions or tasks for JVM. The first one is it loads the code. The other function is it verifies the code. The other one is that it executes the code. The other function is that it provides a runtime environment. It provides a runtime environment. And JVM has got several components. When we talk about loading of source code, and there is a component that is called class loader. There is a component that is called class loader that loads .class files into memory. This one basically loads dot class files into memory. This is the class loader. The other component is bytecode verifier. Bytecode verifier. Bytecode verifier is another component of JVM. And what does it do? This bytecode verifier ensures the code adheres to Java styles rule. It ensures that code adheres to Java style rules, to Java safety rules, or basically Java safety rules. Okay, are we there? Then there is another component of Java. There is another component of Java called not the component of Java, but the component of JVM called interpreter. So what does interpreter do? It executes the code. Basically, it reads and executes. It reads and executes bytecodes. It reads and executes bytecodes line by line. It reads and executes bytecodes line by line. Okay. So the other component, as we talked earlier on, is JIT. That is just in time compiler. Convert bytecodes into native machine code for faster execution. So the other thing is runtime environment. So runtime data area. So for the runtime environment, we have memory. And Java has got heap and stack memory. Basically, we use heap to store objects and arrays. Use heap to store objects and arrays. We also have another memory in Java called stack. We have stack memory. The purpose of stack is to store this basically stores local variables and methods call. It stores local variables and method calls. So that is basically the stack. So that is JVM. We have said that JVM is a Java virtual machines that provides runtime environment for executing Java bytecodes. And some of the function is loads code, verifies the code, executes the code, provide a runtime environment. And some of the JVM component is class loader, which load.class file into memory, bytecodes, verifier, that verifies that the code adheres to Java safety rules. We also have interpreter that reads and executes bytecodes line by line. We also have the heap and stack memory. So heap basically stores object and array, while stack basically stores variables and method call. I want to look at one more concept before we begin our hands-on task. One more concept, JDK, JRE. What is JDK? JDK stands for Java Development Kit, and JRE stands for Java Runtime Environment. So basically, you cannot run Java without mentioning these three: JVM, JDK, and JRE. So these are some of the tools. So the JDK, that is Java Development Kit, is a software development environment used to develop Java application. And this JDK includes So this is a Java development kit. It comes as a bundle, and in it includes JRE, which is Java Runtime Environment. There is also uh, compiler, which for Java the compiler is called Javac, or some call it JavaC. There is debugger. All these are components of JDK. There is also compilers, other tools like Java docs, etc. So basically, if you are very new to Java and you want to get started, the first thing that you will do is to install JDK. You will have to install JDK. Java program cannot run without JDK, and you know that JDK comes with Java runtime environment. There are two options. You can go and download the JDK from Oracle website, or you can use Open JDK. So if you go to Java JDK, you will see some downloads. Also, you can also go with OpenJDK. So we have Java 23, Java 21, and ARIA version available now. As you know, Java has released so many versions. It has released so many versions in the past years, and it took 30 years to make Java developer conference this good. So can see there are various versions of Java. There is JDK 23, JDK 21, and also there are other versions of JDK like JDK 11, JDK 17, and so on. So I would like to encourage you to, if you are for Linux, follow the guide for Linux. If you are for Mac OS, follow the guide for Mac OS. And if you are for the Windows, follow the guides for Windows. You can either download compressed archive or installer, which can be so it is recommended to download this MSI installer and install it. So that is the first step. Okay, are we together up to that point? Then after installing Java, you will go to environment variables. Go to your PC on Windows. You go to your PC, right click properties. So you right click properties. Then you look for advanced system settings, environment variables. But before that, if you go to your PC, basically what you do is you go to program files, go to your programs file, locate Java, then go inside the JDK. In this case, I will be using JDK 17. JDK 17. So click on that JDK 17, click on bin folder, copy this path. If you copy this path, please be very careful because you have to add this path to your environment variables for Java to be, for you not to experience any problems. So you go to these environment variables. If you go to this environment variable, you will see that we have user variables. We also have system variables. So in this case, you will have to add it here on the path. You can come and add it here on the path. Also, you can come and add it here under these paths. So this path for system variable, come and click the path, and then as you can see, I have Oracle Java path and so on. So you can come and click edit, not basically edit but new. You add it there, you click OK. Then there is also Java home. You see this Java home. This Java home is the path to my JDK. You can create a variable, call this Java home, and add a path to your JDK. After doing that, you click OK. Then you can either restart your PC or those settings will be applied automatically. It is through doing that you are able to run, you will be able to run your first Java application. So let us go to our IDE. Throughout this tutorial, I will be using the IDE, that is IntelliJ for Java code. So I have a project called Java Tutorials. I want to go inside the SRC, want to create a Java class, and I am going to call this program Hello World. Hello World. So basically, I want us to write the first Java program. Public static void main string as system.out.println welcome to Java. Welcome to Java. So this is the first Java program that we are going to write. Remember, every Java, for a Java program to execute, there must be a main method. So the main method is the entry point for any Java program. If I execute this hello world, you can see that there is output welcome to Java. So basically, public class hello world, this one defines a class named hello world. The class name must match the file name. This class name must match the file name. Hello world should be the same as hello world. Public static void main string args. The main method is the entry point of the program. This is the main method, and it is the entry point for our Java program. And it prints welcome to Java to the console. So this is how we print. We use system.out.println to print results on the console. So basically, that is how we do it. But if you're not using IDE, you have just created a file, have called it hello world.java. Basically, what you do is you open a terminal or command prompt, navigate to this file directory, compile the program. So up to that point, we have been able to run several things, have been able to know that Java is a versatile object-oriented programming language that is platform independent. We have also been able to know that JVM enables Java's write once, runs anywhere capability. So the next thing that we are going to do, whenever you are running a new programming language or any programming language, basic syntax and data types is a must. Therefore, I want us to go to basic syntax and data type. Basic syntax and data type. Basic syntax and data type. Basic syntax and data types. So under this, we are going to run about Java syntax rules. We are going to run about Java syntax rules. These rules are very important. They are very important. Without this syntax rule, things might be very hard on you. Things might be very hard on you. You might find yourself encountering so many unnecessary errors. The first rule in Java is that Java is case sensitive. Case sensitive. Case sensitive. That means that if I declare my variable name or my name, case sensitive means that my name is different from my name. According to Java, these two are different because of case sensitivity. So it is good to learn that Java is case sensitive. Java is case sensitive. The other rule is that class name should start with uppercase. Class name should start with uppercase letter. Uppercase letter followed by lowercase. Followed should start with an uppercase letter and follow Pascal case. Pascal case is whereby every first word is capitalized. My class. So you can see this rule. If we go to our IDE, we can see that this is Pascal rule or Pascal case. That one, class name should start with an uppercase. I have started with an uppercase and follow Pascal case. Pascal case is whereby every word, if I want hello world Java, every first word should be capitalized. The other rule, these are very important rules that you should put on your fingertips. The other rule is that method names should start with lowercase and follow camel case. Method name should start with lowercase and follow camel case. What do we mean by camel case? What we mean by camel case is that the first letter, if you have more than two words, the first letter is lowercase, while the subsequent start of a word are uppercase. E.g., a method calculate perimeter. So you can see that method name should start with a lowercase and follow camel case. Calculate perimeter triangle. So this is what we mean by camel case. If the first letter of the first word is lowercase, then for each subsequent word, the first letter must be uppercase. So that is what we mean by camel case. Rule number 4. The name of program must exactly match the name class. Program file must match class name. For example, I created a class name called Hello World, and I created a program called Hello World, and a class should be Hello World. It is not possible for me to create, if I try to create a class name that is different from this, it will throw an error. Maybe Hello World, see, you can see it has thrown an error. Hello World should be declared in a file named Hello World C. So that's a very important rule. It's a very important rule. The other rule, and this is very important, every Java application must contain a main method. Every Java application must contain a main method. If you don't have a main method, your code will not be executed because the main class or the main method is the entry point of any Java application. So this is the entry point for Java application. So public static void main. The other one, which is very important, is that each statement must end with a semicolon. Each statement must end with a semicolon. Each statement must end with a semicolon. As you can see, if I remove this semicolon, you get an error. Get this error. See, I have an error here. And if I click, it's saying semicolon expected. So each statement must end with a semicolon. The other rule is that blocks of code are enclosed in curly braces. Code blocks are enclosed in curly braces. Curly braces. What is a curly? These are curly braces. So the code blocks are enclosed in curly braces. You can see these are code block. I must include curly brace. I must include curly brace. Okay. So those are some of the syntax rules in Java. If you understand this syntax rule, it will be very, very important. Now I want us to go to data types. Data types in Java. Just like any other programming language, Java has got various data types. And there are two types of data types in Java. We have primitive data types. We have primitive data type and non-primitive data types. So for Java, primitive data types, we have various primitive data types. And primitive data types are the most basic data types in Java. They are predefined by the language and named by a keyword. There are 8 primitive. So there is a byte. This byte is equivalent. This is the first one. This first one, byte. This has got a size of 8 bits. 1 byte is equivalent to 8 bits. So it stores whole number from -128 to 127. We have short. Short is another data type, and this is 16 bits. 16 bits. We also have another data type called int. Integer is 32 bits. It is 32 bits. So the other one is wrong. The other one is wrong. Wrong is 64 bits. 64 bit. The other data type that we have in Java, primitive data type, is called float. A float is 32 bits. And what is a float? It is store fractional number with a decimal digits. This store fraction, and this fraction has got a decimal digit, 6 to 7 decimals digits. So that is a float. The other one is double. Double is 64 bits. This is 64-bit fraction. This is 64-bit fraction with 15 decimal digits. It has got 15 decimal digits. Number 7 is car. This is 16 bits. What is a car? It is store a single character or ASCII value. Character like A, B, etc. The last one is Boolean. Boolean, this is basically 1 bit. Boolean is 1 bit and it is store either a true or false. It stores a true or false. So these are the 8 primitive data types that we have in Java. Other than that, we have non-primitive data type. Non-primitive data types. We have some non-primitive data types. These are also called reference data types. Reference data types. They are also called reference data types. And they include one, classes. So a classes is a primitive data type, and these include string, it include object, and also some custom classes. Other than that, we have interfaces. We also have arrays. These are some of the non-primitive data types. And non-primitive types are created using new keywords. This one, they are created using new keywords. And refer to object in memory. We also have variables and constants. The other very important concept in Java is called a variable. What is a variable? This is a container that holds a value. It is a container that holds a value. This is a variable. Containers that holds a variable. And the syntax. What is the syntax? Syntax for creating a variable. We begin by data type, then variable name, then value. This is the syntax. Very important. Syntax for creating a variable, data type, variable name, value. Example, I want to create a variable called age. So age will have a data type of int. Age is equals to, I give it value of 31. So these are variable. If I want to create a variable salary, and it will be of type double, I will say double salary is equals to okay. Also boolean is dot is equals to true. So this is how you define a variable. It is basically a container that holds a value. We have constants. Constants are variables whose values cannot be changed once assigned. Values cannot be changed. And we define constant using final keyword. Defined using final keyword. It is defined using final keyword. For example, final double pi is equals to 3.14159. So these are constant. It cannot be changed. This pi is a constant. As you can see, it has been defined using final keyword. So I want us to go very fast because some of these things is just a refresher. If you have ever done programming with any other programming language, you are aware of these things. Then we have operators. It is only that you need to understand these things before jumping into the code. We have operators. So operators are symbols that perform operations on variables and values. They perform operations on variables and values. They perform operation on variables and values. These are the operators, and we have various type of operator. The first one is arithmetic operator, where we have addition, we have subtraction, we have multiplication, And we also have division. And a very good example is a plus b. A plus b, a minus b, a times b, a divided by b. These are some of the arithmetic operation. We also have modulus. Modulus is basically remainder, percentage, like a modulus b, a modulus b, a modulus b. So those are some of the arithmetic operations that we have. We have another operators called relational operators. You are going to see them in real life when we are doing code. This is equals, not equal, greater than, less than, greater than or equal to, less than or equal to. So these are relational operator. They are relational operator because they do some comparison. A is equals to B, like I can say A is equals to B. A is not equal to B. Can also say A is greater than or equal to B. So those are some of the relational operator. Number 3, we have logical operators. Logical operators, we have logical and logical or. Logical and logical or. We also have assignment operators. We have assignment operators like equal to. So basically you assign A to B, equal to. Then we also have another one called, this is called add and assign. We also have another one called subtract and assign. We can also call this pre-increment, pre-decrement. Also have multiply and equal sign. We also have divide and equal sign. Basically, I want to say something. If I have A is equals to A plus B, if I have this, I can write this as short term using assignment operators, like this can be written as equivalent to A plus is equals to B. This A is equals to A plus B is equivalent to A plus is equals to B. Also, A is equals to A times B. This is equivalent to writing shorthand A times is equals to B. A times is equals to B. We also have bitwise operators. We have bitwise operators. So what are some of the bitwise operators that we have? We have bitwise or, this one. We have bitwise not. We have left shift. We have right shift. And we also have unsigned right shift, and so on. So we are going to see all these operators in action. Another important concept when it comes to Java is typecasting. Typecasting is the process. So typecasting. What is typecasting? Typecasting is the process of converting one data type to another. E.g., I want to convert an integer to double. So for me to convert an integer to double, I may say int my int is equals to 10. So basically, this my int is equals to 10. What will happen if I want to convert this my int to double? So I will basically say double my double my double. Basically, I can say double my double is equals to my int is equals to my int. Basically, I have a question. Will this work? This will work. When a small data type is assigned to a bigger data type, like this integer is smaller than double, there is automatic casting. Like for example, if I want to convert this integer 10 to double, it will be automatic. But what will happen if I want to convert double to int? Remember, double is bigger than integer. Therefore, I cannot do automatic conversion. If, for example, I copy this, I paste here, say this is double 10.5, and I want to convert this to int, I will say int my double is equals to, so maybe my double, this is my int is equals to, I cannot just come here and say my double. It is not possible. It will not do automatic conversion. I have to cast. So casting is whereby I will define integer here. So that means that this double will be converted to integer through casting. It will be converted to integer through casting. It will be converted to integer through casting. So I hope you are okay up to that point. I hope you are okay up to that point. The other concept that I want us to look at is called control flow statement. Before we go to control flow statement, in Java, we have what we call comments. Comments in Java. How do we comment in Java? We can comment as follows. This is single line comment, and this is multi-line comment. These are comment that span more than one line. Multi-line comment. So that is how we do comment in Java. That is how we do comment in Java. I want us to go to control flow statements. Control flow statement. So basically, control flow statements are fundamental to programming as they allow you to control the execution flow of your program based on conditions and loops. So we are going to look at if-else statement, switch case statement, and looping statement. So basically, conditional statements allow you to execute different blocks of code based on specific condition. It is like your program is making decision. So, for example, I want us to look at if-else statement. So basically, what is an if-else statement? So the if-else statement is used to execute a block of code if a condition is true. If-else statement, this one executes a block of code if a condition is true. If the condition is false, the else block is executed. So the if part is executed if the condition is true, and the else part is executed if the condition is false. I want us to look at the syntax. What is the syntax? What is the syntax for this? So the syntax is, we say if condition execute statement. This is statement to be executed if true. Else statement to be executed if false. So this is an if-else condition. The if will be executed if the condition is true, while the else will be executed if the condition is false. For example, let us do this practically. Let us advance our code a little bit. Let us say int age is equals to 18. Int age is equals to 18. I want to check a condition. If age is greater than 18, if age is greater than 18, if age is greater than or equal to 18, what do? We print adult. You are an adult. Else we print you are a child. We print you are a child. So I want to explain if else using a code. So basically we have an integer age. Age is equals to 18. Now because this condition evaluate true, this statement will be executed. If I run this code, can see you are an adult. If I put maybe the age is 12 at an age of 12, this true part, age is greater than 20, false. Therefore the else part will be executed, and what will be printed on the console is child. What will be printed on the console is child. So you can see on the console the child is printed. The child is printed. So I can create a new package. I will call control statement. Control statements. And inside here I will create a new Java class called if else. This a class if else, and let me copy this code and put it there. So expected. So yes, close this. Now that is the if else. The other thing that I want us to look at is nested if else. Nested if else. Therefore I will create new. I will come here, create new. Why can't I create a new Java class? Nested if else. So can this if else run? Nested if else. So basically I want to copy this main class, and I want to explain to you what do we mean by nested if else. Nested if else. So we can nest several if else statement. For example, I want to come here and say int score is equals to 85. I define a variable called score. Say if score is greater than or equal to 90, I want to system.out.println grade is A. This person has got a grade A. Else, if score is greater than or equal to 80, if score is greater than or equal to 80, else if score is greater than or equal to 80, want to shout grade B. Else if score is greater than or equal to 70, greater than or equal to 70, shout grade B. This is grade C. Okay, sorry, this should be grade C. Else if, so basically I don't want to go further, I want to close with an else. Else this is grade D. So I have nested several if else, if. This is what we call nesting in Java. Nesting of if else in Java. I want to run this and let us see which grade will be printed. The grade is B, grade B. Why? Because it comes here. Check whether score is 80. 80 is greater than 95, false. Score 80 is greater than or equal to 80, true. Therefore, it will print this and exit. It will print this and exit. What about if I say 71? This part will be executed. And you can use this when building a grading system. Building a grading system. So you see, C is executed. If neither of those, maybe 31, that one, it does not meet this criteria, it does not meet this criteria, it does not meet this criteria, therefore the grade D will be printed. So that is what we call a nested if else statement. Nested if else statement. Those are the nested if else statement. You can see grade D has been printed. Now I want us to go to another control statement called it is called a switch case. Switch case. I want us to look at switch case. So, and I want to give you syntax, the syntax for the switch case. So this is the syntax. So what is the syntax? So you use the keyword switch. Inside here, you put the expression, switch expression, then curly brace for the code block, then you put case value 1 statement to be executed, code to execute, then you break code to execute, you break case 2 value 2, code to execute, break case 3, code to execute, break. Okay, then we have default. So for the default, we have code to execute. So we have code to execute. Okay, so basically this is the syntax of switch case statement. So you have keyword switch, then you put the expression here, then case value 1, assuming we have a value there at the top. So case value 1, if the case is value 1, this code will be executed and break. So what is the purpose of break statement? This break statement is used to exit the switch block. It is used to exit the switch block. Without it, execution will fall through to the next case. Assume, for example, this case is executed, this case matches, and this code is executed. Therefore, without a break, it will automatically go to case 2 and continue. But we want, if a value matches a specific case, execute and break, or rather exit the switch. So the default case is the optional, and it executed if no cases match. So if, for example, I want us to convert our code here to a switch case, let us convert our code here to a switch case. So I want us to convert our code here to a switch case. So what we will do, this is what we will do. We're going to say int score is equals to 85. So I will say switch. So what am I going to switch? I am going to switch score. Okay. Yes, I am going to switch score. Int score is equals to 85. Switch score. Then I will say case 85. Okay. Basically, let us have another example, like the days of the week. So int day is equals to maybe day 1. So I put switch day case 1. If case is 1, I will say out Monday, break. So this one is not required. Break. So I have int day is equals to 1, switch day, and under this I put this expression, turned out Monday, break. I want us to go to case 2. I will tell you why this is misbehaving. Case 2, system.out.println Tuesday, break. I want to go to case 3. Case 3 is Wednesday, break. Then I want to say default. I will say invalid day. Okay, so the reason why it is misbehaving is because this one should be put inside main method. So I will say public static void main string args. So inside my main method, I put that code. So you can see that the error has gone. So basically, day is 1. Therefore, case 1 will be executed. Case 1 will be executed and it will print Monday. It will print Monday. Since you can see it is Monday. If the day is day 3, it will print Wednesday. It will print Wednesday. See Wednesday. What about if case is 9? So what will happen is that day is equals to 9. So each day, case 1. Is 1 equal to 9? No, this will not be executed. It will go to case 2. 2 and 9, they do not match. This will not be executed. Go to case 3. 3 and 9 do not match. We go to default invalid day. And that is what should be executed. That is what should be executed. That is what should be executed. Invalid day. Also, let us maybe take a 2 there. What will happen is that this case 2 will match these 2 and it will print out Tuesday. It will print out Tuesday. But I want to ask you a question. You can see that the moment it prints Tuesday, it exits the switch case. What will happen if I do not have that break statement there and try to run this? If I don't have that break statement there to try to run this, what will happen? Can see it is printing Tuesday and Wednesday. So it is printing. So it print Tuesday, but because there is no statement to exit the switch case, it will continue to case 3. So that is why we have said that is the significance of break statement. So that is all about the switch case statement. Switch case statement. So now I want us to go to looping statement. Looping statement. So I want to go to new Java class, to go to for loop. So looping statement. Let me add a main class, public static void main string args. So what is a for loop? For loop. So looping statement allow you to execute a block of code repeatedly until a condition is met. You execute a block of code repeatedly until a condition is met. We have for loop. The for loop is used when you know how many times you want to iterate. The condition is that you know how many times to iterate. You know how many times to iterate. So I want us to go to syntax. Syntax. The syntax is that we have for, we have initialization, you have condition, then you have increment, decrement, then code to execute. So this is the syntax for a for loop. We have initialization. So we will begin by initialization. We will begin by initialization, then separated by semicolon condition, separated by semicolon increment, decrement operator, then the code to be executed. This is the syntax of a for loop. This is the syntax of a for loop. E.g., for example, I want to print number from 1 to 5. I will say for int I is equals to 1. This is initialization. I have initialized my integer I to start with from 1, and I want to put the condition. I want this loop to run 5 times. I is less than or equal to 5. Then I plus plus, what will I do? System.out.println I want to print I. Want to print I. So rather I want to print I. So what will happen is this. So what will happen is this. So I is 1. So as long as this condition is met, it will print a 1. Then it will increment an I to 2. 2 meets this condition. Yes. Print 2. Okay. Then increment I to 3. 3 meets this condition. Yes. Print 3. Print 3. Increment that 3 now becomes 4. So 4 meets this condition. Yes. Print 4. Increment this I, 4 will become 5. So 5 is less than equal to 5. Yes. Print that. Increment I becomes 6. 6 is less than or equal to 5. False. Stop the execution. So that is for loop. Let us run this. Let us run this code. So you can see it has printed 1, 2, 3, 4, 5. These numbers has been printed. Now there is another type of for loop called for each. For each. For each. For each. Basically, this is an enhanced for loop. This is an enhanced for loop. Like for example, like for example, I have integers. So let me comment out this. I have integer array integer array called numbers is equals to 1, 2, 3, 4, 5. So I want to print these numbers using for each loop. So basically what I will say, for int number in numbers, just print number. What will this print? Not number but num. What will this print? Reprint 1, 2, 3, 4, 5. So basically what it does, it iterates through this number, int num. So num will be 1. So for int num in number, it will go through this number, store the number in variable num and print that number. So it will print 1. Then go to the next one, print, 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 then exit the loop. So that is for loop. The other control flow structure is called while loop. While loop. So public static void main. I want to create a main method. So while loop. So this while loop, what is a while loop? What is a while loop? While loop is used when you want to repeat a block of code as long as a condition is true. You want to repeat a block of code as long as condition is true. You want to repeat a block of code as long as condition is true. So you use a while loop. You use a while loop. So let me show you the syntax. The syntax for while loop is just say while condition code to execute. Code to execute. Code to execute. Code to execute. This is the syntax. While condition, code to execute. And remember, in every loop, there must be a terminating condition. This is the condition that will terminate the while loop. So for example, I want to count 1, 2, 3, 4, 5. Count 1 to 5. Say int count is equals to 1. Okay. We say where count is less than or equal to 5. South count not count 1 but count, print the count. Okay, print the count. Then increment that count, and so on. So if I run this simple line of code, you can see it is printing these counts. It is printing count 1, 2, 3, 4, 5. So basically what is happening is that we have done the initialization that count is starting from 1. Then while count is less than 5. So 1 is less than 5. Yes, print it, increment it. Now count becomes 2. 2 is less than or equal to 5. Yes, print it, increment it. Now it becomes 3. 3 is less than 5. True. Print it, increment it. Now count becomes 4. 4 is less than or equal to 5. True. Print it, increment it. Now it becomes 5. 5 is less than or equal to 5. True. Print it, now increment it. Now count becomes 6. 6 is less than or equal to 5. No, the condition is not true. Terminate. So that is what we call a while loop. The other type of loop is called a do while. Do while loop. Let me generate main method. Public. If you have IntelliJ, you can type public static void main. Public static void main. Enter to generate the main method for you. So do while loop. What is this loop? Is similar to while loop. Similar to while loop. But there is a difference. What is the difference? The block of code is executed at least once, even if the condition is false. The block of code is executed at least once, even if the condition is false. If you want a block of code to be executed at least once, even if the condition is false, use do while loop. Syntax. What is the syntax of do while loop? Just say do. Okay. This is code to be executed while condition. First of all, you execute the code, then you check the condition. Execute the code first, then you check the condition. Then you check the condition. For example, I want to say do. What do I do? What will I do? Say system.out.println count. So let us start by initializing int count is equals to 1. So in Java, plus is used for concatenation. Int count is equals to 1. Do print the count while, so we write the condition while count is less than or equal to 5. Where this is less than or equal to 5. This is do while loop. So let us see the behavior of this do while loop. Let us stop. I think we have not added the term. We have not added the increment count plus plus, because without this it will execute, this loop will execute forever, because it will always be 1 1 1 1 1. This will result into infinite loop and may as well result to stack overflow. So with regard to this, those are the conditional statements. Those are the conditional statements. So we have another very important keyword called continue and break statement. Continue and break statement. The continue statement skips the current iteration of a loop and proceeds to the next. This one skips. No, the continue skips the current iteration of the loop and continue to the rest. Continue to the rest of the code. Continue to the rest of the code. So, like here, if we go to our for loop, our very first for loop here, and demonstrate how to use continue. So I will say if num is equals to 2, continue. If number is equals to 2, just continue. You just continue. You just continue. You just continue. I want us to see the behavior of this continue statement. If number is equals to 2, skip the current iteration and continue. So it will print count 1, 3, 4, 5. Count 1, 3, 4, 5. It has skipped the iteration for 2. Okay? So that is the continue statement. We also have break statement. I told you that is used to exit a loop or a switch statement prematurely. Exit. So if for example, if number is equals to 4, break. Just when it sees a 4, it will break. So it will print 1, 2, 3. Ikiona 4, break. 1, 2, 3, and break from there. So you can see the significance of the break statement and continue statement. So we also have a return statement. Return statement. Return statement. New Java class, rewrite return. So I want to teach you about return statement. So public static void main string args. So what is the purpose of the return? The return statement is used to exit a method and optionally return a value to the caller. Exit a method and optionally return a value to a caller. Maybe I will say public, I will create a method called public static int. This, it has a return type of integer, and I will call this sum. So I will say int a, int b. So basically I will say return a plus b. Return a plus b. So the purpose of this return will be used to exit the method. It will exit this method and optionally return a value to the caller. If this caller calls this, maybe for example shout sum, call this method sum and pass a as 4, b as 5. So it will call this method Basically, this method called sum will be called, and 1 will be passed as 4 and b will be passed as 5. So it will return 4 plus 5, 9. Return 9 to this, and this will print a 9. So that is the purpose of the return statement. That is the purpose of the return statement. You can see that it has now printed a 9. So basically, that is all about control flow statement. That is all about control flow statement. So it is very good for you to understand these concepts very well. So let us continue with the next thing. So the next thing that I want us to look at once with regard to Java is object-oriented programming. Object-oriented programming. Object-oriented programming. So I want us to look at OOP. What is OOP? OOP stands for object-oriented programming. Remember, it is very common for you as a Java developer during the interview to be asked about some of the OOP concept or object-oriented programming concept. So, what is object-oriented programming? This is a programming style. It's a programming style that organizes software design around objects rather than function. Programming style that organizes software design around objects rather than function. This is object-oriented programming. Object-oriented programming. This is very key. Object-oriented programming. It's a programming styles that organizes software design around objects rather than function. So Java support object-oriented programming, and understanding OOP principle is essential for writing clean. So why OOP? The number one reason why you need to understand OOP is to be able to write clean code. You want to write clean code. Number two reason why you OOP is you will be able to write modular code. Number three reason for OOP is that you will be able to write reusable code. And number four, maintainable code. So those are some of the reasons why we should opt for OOP. So what are we are going to look at some of the OOP principles. So before we look at OOP principles, let us talk about classes and objects. Classes and objects. So what are classes? A class is a blueprint of an object. A class is a blueprint of an object. It's a blueprint of an object. So it defines properties. It defines properties or attributes and behaviors. So behaviors are methods. So inside the class we have the properties and we have the methods or behaviors that object created from class will have. That object created from class will have. Yes, that is a class. So syntax, you know the syntax of creating a class. So you know that syntax is class 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 name. Then inside the class, we have said that a class contains attributes. So you define fields, or rather these are the attributes, and you also have properties or other methods. So these are class. And for method, how do you define a method? How do you define a method? So how do you define a field and how do you define a method? To define field, you start with data type, then field name. Data type, then field name. Right? For example, I will say string color is equals to red. String color is equals to red. I have an attribute called color. So what about method? Method you define using return type, method name, return type, method name, then you pass the parameters, then the curly brace. That is how you define a method. Like for example, you can say void start, this is a car, void start. So as you can see, this is the return type void. Void means it will not have a return value. It will not have a return value. So inside here you can say print, just print car is starting, and you know the print statement in Java is system.out.println. So that is a class. What is an object? An object. What is an object? What is an object? An object is an instance of a class. Basically, an object is an instance of a class. It is an instance of a class. It represents real world entity and has a state. It has field and behavior. It has fields and behaviors. It has field and behavior. What is the syntax? Syntax. This is very important. The syntax for an object is very important. We begin by class name, then object name is equals to new class name. Just like that. Class name, object name is equals to new class name. Just like that. For example, I have my class called so inside here class name, let me call this, let me remove this. This is a class name, so let me call this class name car, because we now know the syntax car, class car. So the syntax for an object, maybe I will say class name is car, maybe car object is equals to new car. Now I have created an object called car, and this object is an instance of our class car, and we can use this object to access the methods inside a class. Okay, yes. So maybe I can show you that concept in our code. Assume this is not static. This is not static. So what do we do? What do we do here? What can we do there? So you can say return equals to new return. the return is secure. Return lt is equals to new return. Then I will say system.out.println say rt.sum. So I am using this object to access the sum. So I will run this code. So this is object oriented. I have created a class. So now I want us to go to the object oriented principles, OOP principles. I want us to go to OOP principles. So what are the OOP principles? Without these OOP principles, life might be very hard. So the first principle is called encapsulation. Encapsulation. Basically, what is encapsulation? Encapsulation is the mechanism of bundling data and methods together into a single unit. Bundling data and methods together into a single unit. You bundle, it's the concept of bundling data, or rather the fields and methods that operate on the data into a single unit or class. It also restricts direct access to some of the object's component, which is achieved through access modifier. So under this we have access modifier. This is for restricting access. Access modifier is for restricting access to some of an object component. Yeah. So, and we have various level of access modifier. The first access modifier is private. Anything that is defined as private. You can see here, public. Are you asking yourself, what is public? We have private, we have public. What is public? Access, anything that is defined as private is only accessible within a class. Only accessible within a class. Only accessible within a class. For example, I may write here private int, sorry for this, may write here private int salary, and then inside here I will say int band. So I have band, not band, int rate, int amount. So this will calculate my salary from rate, return rate times amount. Okay, and here, yes. So if I want to call this salary inside here, I will just come and create another object. I will just come and create call this using my object rate. I will call my salary 4 plus 5, and I will run the main method. So you can see the salary is 4 and 20. You can see that I can be able to access this salary defined as a private inside my class. What about if I try to go outside my class and call this? I create an object return. I go to hello world here. Okay, not basically that. I go to yes here, and I just say return is equals to new return. So I am just creating an object to access the methods inside my class return. Then here I just want to print system.out.println. So I will say rate.sum and I pass 5 7. Why is it that I cannot be able to use this sum? Remember, inside my return I have sum and I have salary. Why can't I be able to access my salary from this class? Why can't I be able to access, maybe I say rate.salary, cannot be able to access salary? Why? Because this salary is defined as private and it is only accessible inside the class. So I cannot access it when I am inside another class. So salary has a private access in return. So that is what we mean by private. Now we have another access called protected. Protected, accessible within the class. This is accessible within the class, comma, subclasses, comma, and same package. For example, if I have anything inside this SRC package, it will be accessible as long as it has a protected access modifier. The other one is public access modifier. So this one is accessible from any class, accessible from any class. That is why I created a method called sum inside this return class, and it is of type public, and I was able to access it inside my hello world class. I was able to access it inside another class because it is public. Then we also have the last access modifier called default. What is this default modifier? Default, this means that no modifier has been specified. If, for example, I write void sum, like I have not specified a modifier like public, just void. So this will be default to no modifier has been specified. So which is the behavior if there is no modifier that has been specified? Accessible within the package. So this one will be, the default behavior is that accessible within the package. Accessible within the package. Accessible within the package. So now to access private fields, we use getter and setter. So what are getters and setters? Getters and setters. These are used. They are used to access private fields. They are used to access private fields. For example, let me go back to my return. Let me go back to my return. I want to define a field, private string name. Private string name. No, because we have this static. Okay, let me define it here. Private string name. I want to access this name inside my hello world application. Can I say let.name? No, I cannot be able to access it. But if I want to access this name, I will create a getter and setter method. So maybe I will say private string or public string get name. So here I will return this dot name. Now if I go to here my hello world, I should be able to access let dot get name. You can see I can be able to say let dot get name. Let me set a value. Let me set a value for this. So let me create a setter method here, public string set. We want to set a name. We want to say string name. So I will return name, return name. So if I go here and call this method, I will come here and say string name is equals to let dot set name. I will say Albert, yes. So inside here can be able to print Albert, print Albert. That is how we use setters and getters to access field defined as private. Field defined as private. Why is it that I am not able? Am I inside? I am not able to get this because system.out.println name. Why is this the case? Why can't I set return name, string name? No, basically I say let dot set name and I print let dot get name, like that. Get name using getter. I have set the name to Albert. Now I want to get it using the getter. Don't know why I am not able to get this. Is it because of these conditions? No, not really, not at all. So let me show you how we can fix this inside an encapsulation. I don't know why this one is being printed. This one is the one that is failing. So let me show you a real life example. A real life example of how we can use this. A real life example of how we can use this in a minute. So I want us to create a class. We call this class person. Java class. We call this class person. So we have a class person. So I will define private string name. Person has got a name and a person has got an age. Private int age. I want to demonstrate encapsulation because we are bundling together properties and method. I want to get a getter for name. So I will say public string get name, and therefore I will return name. So I have a getter. So I also want to create a center for name. Public, it will be of type string set name, string name. Okay, this one public has got a typo. I'm going to return, so setter should be void. You are just setting. So this one should avoid, should not have a return. I will say this dot name is equals to name. This dot name is equals to name. So that is how we add getter and setter. We have a class function, have name and age, and we have also bundled together the method to get name and to set the name. Then we can also do the same for age. Private int get age. Then inside here we say return age. We also want to set age. Private void set age. Want to set age int age. We want to give age. This dot age is equals to age. Now we have a method with two fields and also setters and getters. So this is a very good encapsulation. Now I want to create a private static void main string args. Then I will create a new instance of this person. So I will say person is equals to new person. Okay, yes. Now want to say person dot set age 20, person dot set name. I want to set the name to be Albert. Okay, then I want to print system.out.println, say name. What is the name? Name will be person. Name will be person dot get name. I also want to say is person dot get age years old. So we use plus to concatenate in Java. So this will print Albert is 20 years old. Albert is 20 years old. Albert is 20 years old. That is all about encapsulation. So you can see that name. Albert is 20 years old. Not years, but years. And I want to put some space here, and want to remove this name. Just print the name. Albert is 20 years old. That is all about encapsulation. Albert is 20 years old. Now I want us to go to another OOP concept called inheritance. Another OOP concept called inheritance. Inheritance. What is inheritance? So basically, when you see inheritance, this is a mechanism where a child class derives properties and behavior from a parent class. Child class derives properties and behaviors from parent class. So it is like a child is inheriting the behaviors of the parent. That is the inheritance. That is inheritance. So why do we use why inheritance? Why inheritance? Why inheritance? The number one reason for inheritance is to promote code reusability. Anytime you see inheritance, think of reusability. You have created some method in the parent class and you want them to be reusable in the child class. So it promotes reusability. And as it establish a type of relationship called is a relationship. Is a relationship. This is the relationship that is established by inheritance. So let us see the syntax. So the syntax is that we have class, parent, class, we have class called parent class. Okay, so this parent class has got fields and methods. So for you to inherit, you define another class called child class and use keyword extends this class here. It extends parents class. So this extends denotes a relationship. It denotes a relationship. So you can come here. So it will extend all the fields and method of parent class plus additional fields and methods. Additional fields and methods. Okay. Yes. Now I want us to demonstrate this with the help of a code. So I will create a class and I am going to call this class animal. This is the main class called animal. Okay, so it has a method void it. It has a method called void it. And what does this method do? It just output the animal is eating. The animal is eating. Okay, yes, the animal is eating. I want to create another child class, and this time I will call this class dog, and I want to extend animal. So it extends animal. So because it is extending animal, I want to add a void back. Not all animal backs, but dogs backs. And dogs is an animal, therefore it will eat. So I can say dog is barking. Okay, yes. Now here is where I will ask a question. If I put a public static void main for this dog, public static void main. So I go inside this dog and then I call dog equals to new dog. I have an object called dog. An object is an instance of a class. So I want to use dog to access. So I will say dog. So I will say south dog. So I will call dog dot eat dog dot back. Dog dot eat dog dot back. So I have called this code. If I execute this code, what will happen? What will happen with that code? You can see that it has animal is eating, dog is barking. So this animal is eating is a property that is inside the parent class called animal. I also have a dog class. With addition to that, dog being an animal eats and also dog bark. So I can extend an existing class and add other functionality. That is what we call inheritance, and it promotes code reusability. I want us to go to another OOP concept called polymorphism. Polymorphism. This is a concept that allows object to take on multiple forms. Allows objects to take on multiple forms. Allows object to take on multiple forms. It enables a single method or class to have different implementations. So let us look at two types of polymorphism. There are two types of polymorphism. The first one is runtime. The first one is compile time. Compile time. This compile time is called method overloading. Method overloading. Compile time. Method overloading. We also have runtime polymorphism, and this is called method overriding. All these things I am going to show you just in a minute. So what is method overloading? Method overloading occurs when multiple methods in the same class have same name but different parameter. Multiple methods in the same class with same name but different parameters. That is method overloading. Okay. So I want to create a class. I will call this class calculator. Okay. I want to call this class calculator. Then I will say int add int sum. This is a calculator. It has int a comma int b. This will return a plus b. Can I create another method called sum here? Int sum here. Will it work? This is what we call method overloading. What about if I put int a and b? What will happen? If I put int a and b, it will throw error because it checks at compile time. It checks for the method name and the parameter. So you can see the method name and the parameters are the same. Therefore, this is not method overloading. If I change this to double A, double B, and return A plus B, that is method overloading. That is method. No. Those parameters double. This also should be double, not sum. So return. So I have two same method with the same inside the same class with the same name but different parameter and return type. That is method overloading. Can come here and say static void main string args. Can call this calculator. Create an object calculator. Calculator is equals to new calculator. Then I will say south calculator dot sum 530. This will print 35. Can also add calculator dot sum 30.5. So you can see that same methods but doing different things. So that is method overloading. Now let us go back and look at the second one. The second one, which is method overriding. What is method overriding? It occurs when a subclass provides a specific implementation of a method that is already defined in its parent class. Subclass provides a specific implementation of a method that is already defined in the parent or in the parent class. So that is what we call method runtime polymorphism or method overriding, that a subclass provides a specific implementation of a method that is already defined in the parent class. So, for example, let us go to our animal class. Let us go to our animal class. We go to our animal class. So we have a void sound. Let us define another method called void sound. So I will say here, I will say animal makes a sound. Animal makes a sound. Animal makes a sound. What about if I want to go to the dog and this sound has already been implemented in the main class or parent class? I want to use it in our subclass. So what I will do, dog extend. So what I will do, I will come here and override it. I will come here and override it. I will say at override void sound. But now I want to override this sound that is there in my main class or parent class, but instead of just saying animal make a sound, I want to say which sound does this. Yes, animal makes sound, but dog being an animal, which specific sound does it make? Let's say dog barks. It barks. Dog barks. That is the sound made by a dog. So I will come here and say dog dot sound. Dog dot sound. What will happen if I say dog dot sound? Will this work? Will it may say dogs bark? You see now, I've called a dog dot sound. It is not working. So how should I make it work? How should I make it work? How should I make it work? I will call animal class here. My dog say is equals to new animal. Okay. Say my dog dot bark. My dog dot sound. It will go inside my animal class, get that sound and come and override it. Override it. And it will print dog barks. Why is it not doing that? It was my animal, my dog dot sound. My dog dot sound. System dot out dot println and dogs bark sound. Make sound. Dogs bark. Oh, I am running the calculator instead of a dog. Instead of a dog. See, the animal is eating. Because of this, dog dot eat. The animal is eating. Then dog is barking. Dog is barking. Then animal makes sound. So that is how we implement. That is how we implement polymorphism. That is how we implement polymorphism. So I want us to go to the last concept of OOP called abstraction. Abstraction. This is one of the property of object-oriented programming. So what is abstraction? Abstraction is the process of hiding complex implementation details and showing only necessary feature of an object. Hiding complex implementation details and only showing complex and only showing only the necessary details of an object. So you have a method that is doing a lot of work that you don't need to show to other methods. You just show what is necessary. You hide that complex implementation, and we are going to see how we achieve this. It is achieved using abstract class and interfaces. Achieved using abstract class and interfaces. If I am to ask you what is an abstract class, this is a question that is very common even in interviews. What is an abstract class? What is an abstract class? An abstract class is a class that cannot be instantiated and may contain abstract method. A class that cannot be instantiated and may contain abstract method. So it cannot be instantiated, so you cannot create an instance of this class, and it may contain abstract methods. What are abstract methods? Abstract method basically are methods without body. They are a method without body, or in other words, you don't have a curly brace. Those are the abstract methods. Those are the abstract methods. So I want us to implement this in a code. So basically, let me repeat that abstraction is hiding complex implementation details and only showing only the necessary details of an object. It is achieved using abstract classes and interface. So we have started by looking at what is an abstract class. This is a class that cannot be instantiated and may contain abstract method. What are abstract method? These are methods without a body. I want us to implement this. I want us to create a class, and we call this class shape. Class shape. Okay. So, and this class, we should call this abstract class shape. Abstract class shape. We are using a keyword abstract. So abstract class shape. Okay. Abstract void draw. Want to draw. Remember, this method have no body. Tukitoa hii abstract, it will require us to have a body, but because this is an abstract class, it has an abstract method, which means method without body. Okay, Yes, abstract void. So a void draw. Then it can also contain other method with the body. Void display, void display, and in this case I want to say this is a shape. This is a shape. So this is an abstract class. Then I want to create a class called circle. New Java class. I want to create another class called circle. Okay. So this I want this to extend. Extend shape. Extend shape. Now, once I extend an abstract class, I have to implement the methods that are there in the shape. So I will override this draw. So I will override this method draw. I will override this method draw that is inside the shape. So draw. So what should I do? South drawing a shape, drawing a circle. So I am drawing a circle. Now let me define a main class. Public static void main. Then I call the shape class shape to new shape. Now. You cannot say new shape because you cannot create an instance of an abstract class. So then I will say shape.draw, and then I will run this method. So you see drawing a circle. So that is an abstract class. So that is it for OOP. We shall meet in the next session.